We want to factor this completely. That means first we look for a greatest common factor. There is no greatest common factor, so we'll try grouping. What I'm going to do is group the first two terms and the last two terms together. The first two terms have an x squared in common, so if I divide out the x squared, I'm left with x plus 3. The second set of terms have a negative 25 in common. If I divide out a negative 25, I'm left with a positive x and a positive 3. I can see the grouping is going to work because I now have the common factor of x plus 3. So if I divide out the x plus 3 from the first term, I'm left with x squared. If I divide out the x plus 3 from the second term, I'm left with minus 25. Now the first term is the first factor has two terms. They're not squares or cubes, so I can't factor it any further. So we'll leave the first factor. In the second one, though, we have two terms that are perfect squares and it's subtraction. So that means I can break it down into the difference of squares, which is the sum and the difference of their square roots. The square root of the first term is x, square root of the last term is 5, so I have x plus and minus 5. And now each of those is broken down as far as it can be, so that means these three factors are now have this factored completely.